dah. Okay, so hopefully before this lecture you have watched the video on enzyme that you can watch the video dekat YouTube channel, right? So make sure you watch before you attend this lecture, okay, so that it is easier for you to understand what we are going to learn today. Okay, so semua boleh nampak saya punya slide? Boleh? Okay.
Tak
Nampak hitam je.
Nampak hitam je?
Nampak hitam je.
Ini
Ah,
nampak?
dah nampak dah.
Alright. Okay. Okay, so this is the slide, okay, that covers chapter 4. Okay, so basically this is the subtopic that we are going to cover for chapter 4. So there are 9 subtopics for this chapter, which is for 4.1. Okay, we are going to look at the concept, okay, of activation energy. So as you know, activation energy is the initial energy that a chemical reaction requires, okay, to start the chemical reaction, right? So basically, for a chemical reaction to occur, it needs enzyme, okay. So the function of the enzyme is to lowers, okay, the activation energy so that the rate of reaction will speed up, okay, and produce more products, right? Just wait a second, ada orang yang nak masuk. Okay. So the second subtopic is that we are going to look at the mechanism of enzyme action. For this part, okay, there will be two models that we are going to look at, which is the model lock and key model, and then the other one is induced fit model, okay. And then for 4.3, okay, which we are going to look at what are the factors that affects the rate of enzyme reactions. Okay, so you have several factors that will affect enzyme reactions, such as, for example, temperature. Okay, so every enzyme will have its own optimum temperature, and if the temperature increases above, okay, the optimum temperature, it may cause the enzyme to denature. And then another factor that affects enzyme rate of reaction is it can be pH, or the concentration of enzyme, the concentration of substrate, and also the presence of inhibitors. Okay, so inhibitors will also affect the rate of enzyme reactions. And then for the 4.4, we are going to look at Michaelis-Menten Kinetics and also Lineweaver-Burk Plot. So for this one, there are two graphs, okay, that you are going to understand what is the function of these two graphs, okay. And then for 4.5, we are going to look at cofactors, right? So what are cofactors? What is the importance of having cofactors in the enzyme reaction, okay? And then for 4.6 is enzyme inhibition. So for this one, we are going to look at the different types of inhibitions and also the different types of inhibitors, right? So we can classify inhibitors based on how the inhibitors bind to the enzyme. Okay, so inhibitors can bind to the enzyme at the active site of enzyme, or it can bind to the allosteric site of enzyme. Okay, so as you know, the active site of enzyme is where substrate will bind. Okay, and then an enzyme also has another site where you can have inhibitor that binds to the allosteric site that can change the shape of the enzyme and causes the enzyme to be not functional anymore. And then you can have another molecule which is activator. Okay, so this activator can also bind to the allosteric site and change the shape of the enzyme in the active form so that the enzyme can catalyze the chemical reaction. Okay, So you can also classify enzyme on how the enzyme binds, okay, binds to the and how the inhibitor binds to the enzyme, whether it binds temporarily or permanently. Okay, so that one we call it as reversible inhibitor or irreversible inhibitors. Okay, and then for 4.7, regulation of enzyme activity. So this one we are going to look at feedback inhibition, and also the other one is allosteric regulation, and the other one is cooperativity. Okay, three types of enzyme mechanism of enzyme action. And then 4.8 is classification of enzymes. Okay, so we are going to look at how enzymes are classified. Okay, so there are 6 classes of enzyme. We can classify enzyme into 6 classes based on how the enzyme catalyzes the reaction. Okay, so for example, we can if the enzyme involved in the oxidation reduction reaction, okay, that involves the transfer of electrons, okay, from one substrate to another substrate, that one we can classify the enzyme as oxidoreductase. Okay, you can also classify enzyme if the enzyme involved in breaking of bonds, and in order to break bonds, it requires water molecules, such as, for example, you can have maltase, okay, that breaks maltose into its monomer, which is glucose and glucose. Okay, so the reaction requires water. So this type of enzyme, we can classify the enzyme in the group of hydrolase. Okay, so basically there are 6 classes of enzyme that we are going to look at. And then the last one is 4.8 is enzyme technology. So for this one, we are going to look at the concept of immobilized enzyme and what is the benefit of immobilized enzyme in the industry. Okay. So these are the learning objectives. Okay, so the first one is explain how an enzyme lowers the acquired activation energy of activation for a reaction. Okay, so every reaction requires activation energy. Okay, so if the reaction involve enzymes, okay, the enzyme will lower the activation energy and speed up the rate of reaction. If the reaction, for example, doesn't involve enzyme, the reaction may occur, but it takes a long time, okay, for the reaction to occur. Okay, so this is because the substrate needs to absorb heat, okay, heat energy from the surrounding, and then only the substrate can be converted into the products. Okay. And then the second learning objective is to explain the mechanism of enzyme action and describe the hypothesis related to its mechanism of action. So this one, we are going to look at 2 hypotheses or 2 model, which is, as I said before, is lock and key model and also the induced fit model. Okay, there are 2 models of enzyme action. Okay, and then the third one is explain the formation of the enzyme substrate complex. Okay, so as you know, every enzyme, okay, will have its active site that is specific to bind to specific substrate. Okay, so once the substrate bind to the active site of enzyme, it will form the enzyme substrate complex. Okay, before the substrate is then converted into products. Okay, and then the next one is explain factors that affects the enzymatic reaction. So you have several factors. You have the temperature, you have pH, you have concentration of enzyme, concentration of substrate, and also inhibitors, okay, that affects the rate of enzyme reactions. Okay, so every enzyme will have its optimum, okay, optimum factors for the enzyme to catalyze the reaction. Is every enzyme has its own optimum temperature, optimum pH, okay, and then you can have different concentration of enzyme and substrate, okay, that also affects the rate of enzyme reactions. And obviously, if you add inhibitor, for example, into the reaction, the inhibitor will slow down the rate of reaction, or it can even stop totally the enzymatic reaction. Okay. And then the next one is explain the model of enzyme kinetics. Okay, so for this one, we are going to look at Michaelis-Menten Kinetics and also the Lineweaver-Burk Plot. Okay, so for this one is where it says explain the double reciprocal plot of enzyme kinetics. So this one we are going to look at the graph for the Lineweaver-Burk Plot. Okay, and what is the significance of this graph? And then the next one is list types of cofactors. Okay, cofactors, you are going to look at what is actually cofactors and how do you classify cofactors and what is the significance of having cofactors in the enzyme reaction. Okay, basically cofactors are non-protein molecule or ions, okay, that are found usually in the active site of enzyme. And by having these cofactors, the cofactors will help, okay, or it aids in the enzymatic reaction. It can activate the enzyme, for example, or the cofactors can even involve in the chemical reactions. Okay, so there are several types of cofactors, such as you can classify the cofactors into metal ions. Okay, for example, you can have calcium ion or zinc ion that acts as cofactors, okay, for certain enzyme. And then the next one is discuss the mechanism of enzyme inhibition. So as I said, you can classify the enzyme based on where the enzyme bind to. Okay, so if the enzyme binds to the active site, we classify the enzyme as competitive inhibitors. Okay, if the inhibitors bind to the active site of enzyme, we call it as competitive inhibitors. Why do we call it as competitive inhibitors? Because the inhibitor will compete. Okay, will compete with the substrate to bind to the active site. So it means that if you have a competitive inhibitor in the reaction, the inhibitor will compete with the substrate to bind to the active site. If the inhibitor binds to the active site, then the substrate cannot bind to the active site, and so therefore the rate of reaction will slow down and eventually stops. Okay, but you can overcome the effects of a competitive inhibitor by increasing the substrate concentration. Okay, so the more that you add substrate into the reaction in the presence of competitive inhibitor, so it means that you have higher chance, okay, for the substrate to bind to the active site. Okay, so that is how you overcome competitive inhibitor, by increasing the concentration of substrate. So that is competitive inhibitors. The other one is a non-competitive inhibitor. So for this one, for this type of inhibitors, the inhibitor will bind to the active site. Okay, so that's why we call it as non-competitive inhibitors. This type of inhibitor will not compete with the active site. Will not compete with the substrate to bind to the active site, but instead it binds to the allosteric site. So what is the effect? The effect is that once the inhibitor binds to the allosteric site, it causes the shape of the enzyme to change. Okay, once the shape of the enzyme changes, it also affects the shape of the active site, and so therefore substrate cannot bind to the active site, and so the rate of reaction will slow down and eventually stops. Okay, so for this type of inhibitors, you cannot overcome the effects of the inhibitor by increasing the substrate concentration. Okay, so it does not affect by you increasing the substrate concentration, because the inhibitor will just bind to the allosteric site. Okay, and causes the shape of the enzyme to change. And then that will lead to the next one, okay, which is explain what is allosteric site. Okay, so as I've mentioned, allosteric site is another site on the enzyme, okay, where it binds to activator or inhibitor. Okay, substrate will not bind to the allosteric site. Substrate will only bind to the active site of the enzyme. Okay, so so the next learning objective is to discuss, okay, how enzyme inhibitors and activators regulate enzyme activity in a cell. Okay, so inhibitors and activators will only bind, not only, but it can bind to allosteric site or active site. Okay, so So inhibitors and activators can bind to the allosteric site and causes the enzyme to change shape. If inhibitor binds to the allosteric site, it causes the shape of the enzyme to be in inactive form. Okay, but if activators bind to the allosteric site, it can change the shape of the enzyme into the active form. Okay, so that the enzyme can catalyze the reaction. So the next one is list the classes of enzyme and explain its role. So basically, there are 6 classes of enzyme. Okay, based on how the enzyme catalyzes the reaction. Okay, and then the last one is discuss the importance and the main techniques of immobilized enzyme. So this for the last one, we are going to look at what is immobilized enzyme, how does immobilized enzyme works, okay, and what is the significance of immobilized enzyme, especially in the industry. Okay. Okay, so for 4.1 is catalysis and concept of activation energy. So first you have to know the characteristics or the property of enzyme. Okay, so most enzyme are globular proteins. Okay, so we have looked at what is the concept of globular proteins in chapter 1. Okay, so globular proteins are protein that fold into specific shape so that this protein can attain its functional form. Okay, so as you know, enzyme have its active site. Okay, so that's why the enzyme has to be folded into specific shape so that it can form the specific shape of the active site. So that's why enzyme has to be made up of globular proteins. Okay, so you have another types of protein, which is what? Fibrous protein. So fibrous protein is to form structures within cells. Okay. So that is globular proteins. So globular proteins, they attain the tertiary level of protein, or the quaternary level of protein. That is globular protein. They fold into specific globular shapes. Okay, and then the second one, they act as biological catalysts. Okay, biological catalyst, it means that the enzyme involved in catalyzing reactions. Okay, especially reactions that involve in cells, in living cells. Okay, and then they are required in small amounts. Okay, so an enzyme can catalyze the reaction, and once the enzyme catalyzes the reaction, the enzyme can be used over and over and over again. So that's why you only require a small amount of the enzyme, because they are not consumed. Okay, they are not consumed by the reaction, or they are not changed. Okay, the shape of the enzyme will not change. So that's why they can be used over and over again. So therefore, they are required in small amount. And then each enzyme, okay, will have their own specific shape of active site that binds to specific substrate only. Okay. So the reaction the enzyme catalyzes is very specific. So you can have the enzyme maltase and the substrate is maltose, but the enzyme maltase cannot take phospholipid, for example, as its substrate. Okay, so because the shape will be different from the shape of the active site. And then the enzyme can be affected by factors such as temperature, pH, substrate concentration, enzyme concentration, and inhibitors. Okay, so for every enzyme, they will have their own optimum temperature, optimum pH, and also this also can affect the rate of reaction. Okay, so by having enzyme in the reaction, the enzyme will speed up the rate of the chemical reaction without being consumed. So how does the enzyme speed up the rate of reaction? By lowering the activation energy for the reaction. Okay. And then the last one, does not alter the nature and or property of the end products. Okay. So you have a substrate, and then the enzyme will catalyze the reaction by the substrate binding to the active site and produce a certain product at the end of the reaction. But without enzyme, okay, the substrate can also be converted into the product at the end of the reaction, the same product. Okay, but without enzyme, the reaction will take a longer time to occur, okay, because the substrate needs to absorb, for example, thermal heat from the surrounding, okay, in order to overcome the activation energy barrier, okay, to start the chemical reaction. Okay, so how does the enzyme lowers the activation energy barrier? Okay, so the first one is that the enzyme will bring the substrate together into the correct orientation. So it means that the enzyme can have one or two or more substrate that binds to the active site. Okay, so by having the active site, the substrates can come together in the correct orientation or position by binding to the active site. So once they are oriented in the correct orientation, then only the chemical reaction can occur. Okay, and then second, provide a favorable cellular microenvironment. Okay, so what you mean is that the active site will provide a more conducive environment for the reaction. Okay, and then the third one, the enzyme will stretch the substrate bonds towards their transition state. Okay, so by how does the substrate enters into the transition state is by stressing and bending the chemical bond that must be broken during the reaction. So once the substrate binds to the active site of the enzyme, it forms what? The enzyme substrate complex. Once the enzyme substrate complex has formed, the substrate will enter into a transition state. Okay, transition state. What happens during this transition state? The bonds within the substrate will start to be broken, and a new bond will start to form. Okay, so that is a transition state. Before the substrate is converted into product, the substrate will enter into transition state where this will happen. Okay, the bond will be broken to form new bonds. Okay, so the next one, the last one is form temporary covalent bond with substrate. So the enzyme will form temporary covalent bond with substrate. The enzyme can involve directly in the chemical reactions. So that is the function of the cofactors. The cofactor within the active site of the enzyme will, for example, extract electrons. Okay, extract electrons from the bonds of the substrate. Okay, and then form new bonds, form new covalent bond, for example, for the substrate before it is converted into products. Okay, so the next one is activation energy. So what is activation energy? Okay, so this is activation energy. So they are known as free energy of activation. So every chemical reaction requires every chemical reaction between molecules involve bond breaking and bond forming. So in order to break bonds and to form new bonds, so the chemical reaction will have their own activation energy. Okay, so it is the initial energy needed to start a chemical reaction, or it is the initial or the minimum amount of energy to start the chemical reactions. Okay, so often supplied in the form of thermal or heat energy from the surrounding. So if the reaction doesn't have an enzyme, okay, the reaction still can occur, but it takes a long time because the substrate needs to absorb heat energy from the surrounding in order to overcome the activation energy barrier. Okay, so the next one is free energy, or G here. Okay, the symbol is G. So what is it? It is the available energy to do work when temperature and pressure are uniform, as in all living cells. So free energy is the amount of energy or the available energy for cell to do work. Okay, so within cell you can have many types of work, such as, for example, chemical reaction, movement of substance across cells. Okay, so that requires energy. Okay, so this diagram, it shows you how the enzyme lowers the activation energy. Okay, basically the first one you have here is the substrates. Okay, so an enzyme can have one or two or even more substrate that binds to the active site. Okay, so enzyme changes shape such that its active site enfolds the substrate. So once the substrate binds to the active site, okay, you have the active site of enzyme, you have the substrate here, and then once the substrate enters into the active site, the active site of enzyme can change, okay, so that it fits perfectly with the substrate. So this one we call it as the induced fit model, okay, induced fit model. And then substrate held in active site by weak interaction, such as hydrogen bonds and also ionic bonds. Okay, and then the third one, active site then lowers the activation energy, and once the activation energy is reduced, okay, then the reaction can speed up, and then the substrate are converted into products. So now the products, okay, will have a different shape from the substrate, and the shape of the product is also different from the active site. So therefore the product will be released, okay, from the active site, and then the enzyme is free again, okay, to catalyze the next reaction. Okay, so that's why enzyme can be reused, okay, over and over again, and they are required in small amount. Okay. And then this graph, it shows you the difference in the rate of reaction for reaction with enzyme and without enzyme. So the black graph here, it shows you the rate of reaction without enzyme. Okay, the rate of reaction without enzyme, and the red graph here is it plots rate of reaction with enzyme. Okay, so this is the reactants. Okay, so you have this here, you have the reactants, and if the reaction occurs without enzyme, as you can see, it takes a longer time for it to occur to produce the product. Okay, and the activation energy is larger. Okay, activation energy is larger, but when you add enzyme to the reaction, as you can see, it lowers the activation energy, and it speed up the rate of chemical reaction. So the rate will speed up. Okay, and this delta G is a change in free energy. Okay, delta G is a change in the free energy. It is the same for the reaction with enzyme or without enzyme. Okay, the delta G is unaffected by enzyme. Okay, so this is the transition state. Once the reactant bind to the active site of the enzyme, it forms the enzyme substrate complex and causes the substrate to enter into transition states, where bonds within the substrate will start to break and form new bonds before it is converted into products. That is transition state. Okay. So 4.2 is mechanism of enzyme action. So we have two hypotheses or two model for this subtopic, which is the lock and key model, and then the other one is you have the induced fit model. Okay. So so what is lock and key model? It is it says here, active site of enzyme and substrate have complementary shape. So the term lock and key is just an analogy to show you how the enzyme works. Okay, so as you can see, so this is the lock that reflects the function of the enzyme. So as you know, enzyme has active site, okay, specific shape of the active site, and then obviously lock will have its own specific key. Okay, because the shape of the key will fit the hole that is found in the lock. Okay, so this hole reflects the shape of the active site. Okay, so only specific substrate that has shape that complements with the shape of the active site will enter into the active site and bind to the enzyme and forms the enzyme substrate complex. So only specific key will enter to the into the hole of the lock to form the lock key complex. So this is just an analogy. So maksudnya kat sini bentuk lock tu akan complement dengan the shape of the key. Okay, so So the shape will not change. Okay, the shape of the log and the shape of the key will not change. Same goes to the active site of the enzyme will not change. And it complements with the shape of the substrate. Kat sini awak kena take note, you have to use the correct term. The active site and the substrate have complementary shape. Tapi kalau awak explain kat situ, contohnya awak guna istilah the active site and the substrate have the same shape. Salah They are not same, but they complement each other. Okay, complementary shape. Kalau same macam ni, faham tak? So dia tak boleh nak masuk. Kan kalau same. Tapi kalau complement, so the shape will complement each other, saling melengkapi. Active site dengan substrate punya shape saling melengkapi. They complement each other. Do not use same. Do not use similar. Lain istilah dia. Okay, lain maksud dia nanti. So complementary shape. And then it forms the enzyme substrate complex. And then it forms what? It causes the substrate to enter into transition state where bonds are broken, old bonds are broken and form new bonds. Okay. And then the substrate will be converted into products that has different shape. So because the products has different shape, so therefore the product will be released from the enzyme and the enzyme is free to catalyze the next reaction. Okay, so that is the log and key model. The second one is the induced fit model. So for this one, it says here the active site of enzyme is not complementary to the shape of the substrate. So the shape of the substrate and the shape of the active site is different. Okay, so they are not they do not complement each other. But okay, as the substrate nears the active site and start to bind to the active site of the enzyme, okay, the active site will be slightly triggered or induced to change slightly. Okay, so induces slight conformational change of the active site, making the substrate fit more precisely into the active site of the enzyme. So here is the active site of an enzyme. Here you have the substrate. Okay, so the shape is different. They do not complement each other. But once the substrate starts to enter into the active site will be induced, okay, to change slightly its shape, okay, and then once the active site changes according to the shape of the substrate, okay, so this causes a more precise fit, okay, between the substrate and the active site, so to form the enzyme substrate complex, okay. So it says the next point here, catalytic groups on enzyme is in the correct orientation with the substrate. Okay, within this active site will have catalytic groups, which is, for example, you can have the cofactors that involve in breaking the bonds of the substrate and form new bonds. Okay. And then products will be formed that has different shape from the substrate, okay, and also the active site. So therefore, the product will be released. And the last point here, you have to take note, okay, the enzyme returns to its original shape, okay, and can be reused. Okay, so this point is a bit different from the from this lock and key model. Okay, lock and key model macam tu lah shape active site, macam tu lah dia pada akhir dan pada mula dan akhir reaction. Tapi kalau induced fit model, enzyme ni bila dalam reaction tu dia change shape kan, it is induced to change its shape slightly, okay, but at the end of the reaction when product is released, the enzyme will return to its original shape and can be reused again for the next reaction. So ini adalah poin-poin yang awak kena take note lah selalu kalau dalam macam contohnya exam. Okay, bila dia tanya pasal lock and key model ataupun induced fit model, soalan dia selalunya dalam 3-4 markah. Okay, so ini adalah poin-poin yang awak kena take note yang saya highlightkan merah ni. Okay, complementary shape, from enzyme substrate complex, product different from the enzyme and the product is released. Yang ni paling penting kalau lock and key. Active site and substrate have complementary shape. Tapi kalau yang induced fit, ini dia punya point yang awak kena take note. Not complement, the active site not complement to the substrate, induce like conformational change of the active site, and then all that breaking bond, product form, and then yani, enzyme returns to its original shape, okay, at the end of the reaction and can be reused. Okay, soalan macam ni kalau keluar exam, worth mark dia 3-4 markah macam tu. Okay. Okay, so the next subtopic is factors affecting enzyme activity. Okay, so there are this one here, it listed 4 factors that affects enzyme reaction: enzyme concentration, substrate concentration, temperature, and also pH. Okay, so we are going to look at for the first factors, which is enzyme concentration. Okay, so the first point here, it says rate of enzyme reaction is directly proportional to the enzyme concentration. So here you have a graph. Okay, a graph for the y-axis is the rate of reaction. Y-axis. X-axis is the enzyme concentration in percentage. Okay, so the straight graph here can only be produced, okay, if you keep on adding the enzyme. Okay, keep on adding enzyme to the reaction, enzyme concentration increase, okay, as the reaction progresses. And in order to get this graph, okay, you can only the reaction can only be achieved if you have excess substrate. Okay, so here substrate concentration is not the limiting factor, means that you have excess substrate in the reaction, you have high amount of substrate in the reaction in order to get this graph. Okay, rate of reaction is directly proportional to the enzyme concentration if you have excess substrate. Substrate concentration is not the limiting factor. Sentiasa ada substrate untuk enzyme to catalyze reaction. Sebab kat sini sekarang ni awak keep on adding enzyme to the reaction kan. So in order to get this type of graph, direct proportional increase of the reaction is when the substrate concentration is not limiting. Okay, you always have substrate in the reaction. Okay, so as the enzyme concentration increases, okay, this one here, the rate of enzyme reaction increases linearly, this graph, the linear graph here, because there are more enzyme molecule available to catalyze the reaction. Ideal if substrate is in excess concentration. Okay, you always have substrate in the reaction. So in this case, substrate is not the limiting factor. Sentiasa ada substrate untuk enzyme to catalyze reaction. But the next graph here, the one that reaches its maximum rate here is when the substrate is the limiting factor. Okay, you have certain amount of substrate, okay, for the enzyme to catalyze the reaction. So if you keep on adding enzyme to the reaction, but you have limited amount of substrate, okay, at some point the reaction will reach its maximum rate of reaction because there is no more substrate for the enzyme to catalyze, okay, to catalyze the reaction. Okay, so this is the graph here. Okay, so where the amount of substrate is the limiting, the graph will reach its maximum rate of reaction. Okay, so substrate concentration is the limiting factor. So adding more enzyme to the reaction, okay, is no use. No point of you adding enzyme, but you have limited amount of substrate. So this produces this graph. Okay, the reaction reaches its maximum rate of reaction. Okay, the graph would plateau at a certain maximum rate because there is no more substrate for the enzyme to work on. So ini untuk enzyme concentration lah. So enzyme is not the limiting factor. You keep on adding enzyme, but if you have certain substrate concentration, the graph will reach its maximum rate of reaction. Okay. So the next one is substrate. The next factors is substrate concentration. Okay, so this is the y-axis is rate of reaction. Okay, the x-axis is substrate concentration. Okay, for this one you keep on adding substrate to the reaction, so you produce this type of graph. So it has point A, point B, and also point C. So we are going to look at each point. Okay, so point A. As you see, the rate of reaction increases with increasing substrate concentration. So this is because more substrate binds to the active site of the enzyme. So this is here, okay, here, this part here of the graph, it shows you the rate of reaction increases very fast, okay? So because you have plenty amount of enzyme to catalyze the substrate, okay, the substrate. You have plenty amount of enzyme to catalyze the reaction. But okay, as you keep on increasing the substrate concentration, you see here, the rate of reaction starts to slow down. Okay, dia tak setinggi macam ni, nampak? So this is a rapid increase of rate of reaction because you have plenty amount of enzyme to catalyze the reaction to bind to the substrate. But if you keep on increasing the substrate concentration, but you have limited amount of enzyme, okay, so the reaction will start to slow down. Okay, the rate of reaction increases but lower rate because less active site is available. So here, enzyme is the limiting factor. Okay, enzyme here will become the limiting factor. Okay, so maximum rate reaches. Okay, maximum rate reaches because all active sites are saturated with substrate. So what does it mean? If you keep on increasing the substrate concentration but you have limited amount of enzyme, okay, so by adding more substrate to the reaction, it causes all of the active site of enzyme, okay, will be bound to the substrate. So it means that the enzyme is now saturated with substrate, okay, saturated with substrate. So all the active sites of the enzyme molecules are already occupied by substrate. So here, enzyme concentration becomes the limiting factor. Okay, so kat sini dia akan reach maximum rate of reaction sebab apa? Semua active site enzyme tu ada substrate. Okay, so no use, okay, of you adding more substrate if you have limited amount of enzyme in the reaction. Okay, so this will reach its maximum rate of reaction. Okay, so the next factor is temperature. Okay, temperature. So in this graph, you have 4 point. Graph A, okay, the dotted line here. Okay, graph B, okay, the blue line here, and then point C, optimum. It shows you the optimum temperature, and then point D is where the enzyme or the rate of reaction will start to decrease, okay, due to you increase the temperature above the optimum temperature. Okay, at this point D, it causes the enzyme to be denatured, and so therefore the rate of reactions slow down and then stop at some point because all the enzyme has been denatured due to the high temperature. Okay, so kita tengok satu-satu graph A ni, alright, the dotted line here. So as temperature increase, okay, the x-axis shows you temperature, the increasing temperature. The y-axis is rate of reaction. Okay, so as temperature increases, enzyme stability decreases. Nampak? As you increase the temperature, the enzyme stability will start to decrease. So nampak? Sebab itulah graph dia ke bawah macam ni. Okay, the more you increase the temperature, enzyme stability decreases. Why? Because the bonds within the enzyme, okay, within the protein, the enzyme will start to break and causes the shape of the enzyme to change and causes the shape of the active site to change. So as you know, enzymes are made up of globular protein. They fold into specific shape. Okay, so what causes the enzyme to fall into the specific shape? Ini awak kena ingat balik chapter protein hari tu kan? Chapter chapter 1, macromolecule on that explains on protein. So in order for the protein to attain a certain shape, so they will fall into specific shape. So that is the tertiary level of protein. So what are the interaction involved? It involves what? Four or five different interaction. You have the hydrogen bonds, they are weak bonds, and then you have ionic bonds, and then you have disulfide bridge, hydrophobic interaction, and van der Waals interaction. So this bond will hold the protein or the enzyme into specific shape. But if you keep on increasing the temperature, this will cause the bonds that hold the shape of the enzyme to start to break, especially, for example, hydrogen bonds. Okay, so once the weak bonds is broken, so therefore the enzyme loses its functional shape. Okay, functional shape. So it causes the enzyme to change shape, active site changes shape, and so therefore the enzyme cannot function anymore to catalyze the reaction because substrate cannot bind to the active site. So point B here, okay, the graph B here. So as you increase the temperature, okay, what happened is that you have more collision, okay, more collision between the active site of the enzyme and the substrate. Okay, so by increasing the temperature, the substrate will have more energy to move, and also the enzyme will have more energy to move, and the chances of them meeting together to form enzyme substrate complex will increase. So as you increase temperature, you have more collision, more movement, okay, between substrate and the enzyme. So they have higher chance of meeting each other to form the enzyme substrate complex. Okay. So it says here, for every 10 degrees rise in temperature, the rate of reaction will double. Okay, every 10 degrees, rate of reaction will double. So it leads to here, temperature coefficient, which is Q10. So this is the formula, T plus 10 degrees Celsius divided by temperature degrees Celsius. Okay, the unit is in degrees Celsius. So once you calculated the value, so the unit will cancel off. So it means that for Q10 value, it does not have any units. Okay, once you calculated the value, it just gives you a number to show whether the rate of reaction doubles or triples. Let's say, for example, after you calculated this value, okay, this formula, for example, it gives you a value of 2. Okay, Q10 equals to 2. So it means that the rate of reaction increases or doubles. The rate of reaction will double, okay, every 10 degrees. Tapi kalau dia bagi value kat sini 3, for example, so that indicates the rate of reaction triples, okay, for every 10 degrees rise in temperature. So ingat ya, temperature coefficient does not have any units. Okay, the value, okay, for Q10 will just tell you whether the reaction has double or triple, macam tu. Okay. Okay, so the next point is point C here, okay, which is the optimum temperature. Okay, so it says here the optimum temperature balance between enzyme stability and also kinetic energy. So it is the maximum rate of reaction, and it is the point where enzyme is most active. Okay, most active. So every enzyme will have its own optimum temperature. For example, the enzyme in your body, okay, the optimum temperature for enzyme in your body to work is according to your body temperature, which is 37. But if you keep on increasing the temperature, okay, so it may cause your enzyme to be less active, and so therefore rate of reaction will decrease. Okay. Sama juga kalau macam let's say, for example, if you look at bacteria that lives in hot spring, okay, water in hot spring, okay, so the bacteria can only live in that condition because the enzyme of the bacteria will only be in active state at high temperature. Okay, at high temperature. If you take, for example, the bacteria and put it in a pond at your home, for example, where the temperature is around 20 plus, can. So the bacteria will not be able to survive because the enzyme of the bacteria cannot function. It is not in the active state, okay? Because the enzyme cannot reach its optimum temperature for the enzyme to catalyze the reaction within the bacteria, okay? That allows the bacteria to be able to survive. So that is optimum temperature. And then the next point here, D, okay, where you keep on increasing the temperature above the optimum temperature. So you have the heat energy, okay, that causes the enzyme molecule to move violently or vigorously, okay, so due to the high kinetic energy, okay, so that will cause the enzyme to be denatured because the 3D structure or the functional shape of the enzyme is now destroyed, okay, disrupt the 3D structure of the enzyme. So enzyme denatures. So once the enzyme denatures, the enzyme loses its shape, its functional shape. So substrate cannot fit into the active site, and so therefore the rate of reaction stops kat sini. Okay. The high temperature causes the molecule of the enzyme to vibrate violently, vigorously, okay, due to the high kinetic energy, and causes bond within the enzyme to be broken, and enzyme loses its shape, and so therefore enzyme is now considered as denatured. Okay, so the enzyme cannot function anymore, and rate of reaction will stop. So this slide is explains to you on the Q10 temperature coefficient. Okay, so so here if you have the optimum temperature for the enzyme to works, which is 37 for example. So this is a graph that that can be the enzyme within your body. Okay, the optimum temperature is 37. Okay, so as you keep on increasing the temperature, the rate of reaction will increase. Okay, Q10 is it tells you whether the temperature doubles or triples. Okay, so but if you go beyond the optimum temperature, it causes denaturation. Okay, so Q10 is the factor by which, okay, rate of reaction increases with every 10 degrees rise in temperature. So this is the formula. So if Q10 is 2, okay, the rate of reaction doubles with every 10 degrees rise in temperature. If the value of Q10 is 3, so it means that the rate of reaction triples. So remember, Q10 does not have any units. Nampak? They akan cancel off the units. Okay. So, but at high temperature, it causes the protein to be denatured. Okay, sebab apa? As you increase the temperature, it causes the molecule to have high kinetic energy and causes the enzyme to vibrate violently or vigorously, and breaks the bond within the enzyme molecule and causes the molecule to lose its shape. Causes the enzyme molecule to lose its functional shape. Okay. So here you have a graph, okay. Yang ni saya tambah, tapi graph ni awak boleh jumpa banyak dalam buku. Dalam buku Campbell, dalam buku rujukan awak. Okay, so here you have two enzymes. Okay, typical human enzyme that the optimum temperature is according to the body temperature, which is 37. Okay, so as you keep on increasing, the temperature rate of reaction increases. But if you go beyond the 37 degrees, the enzyme will start to denature. And then, so this is the enzyme for thermophilic bacteria. Okay, bacteria that lives in hot spring. They can tolerate heat. Okay, so the optimum temperature for this enzyme in the bacteria is 77. Okay, is 77. So if you go beyond this temperature, so the enzyme of the bacteria will start to denature and causes the bacteria to die lah. Okay, but if you were to place the bacteria in a pond of lower temperature, so as you can see, they cannot survive. Okay, they cannot survive due to the enzyme of the bacteria cannot achieve its active state. Okay. Sekejap ya. Ada orang nak masuk tadi. Okay, so the last factor here is pH. Okay, pH. So every enzyme will have their own optimum pH for the enzyme to catalyze the reaction at maximum rate of reaction. Okay, the enzyme is most active. So as you can see from the graph here, you have two types of enzyme. So the pepsin. Okay, pepsin are enzymes that are found in the stomach. Okay, the function of enzyme pepsin is to digest or hydrolyze or break down protein, okay, from the food that you eat, the meat that you eat, the chicken that you eat, for example, contains protein. So that is the function of pepsin, to break down protein in the stomach. So in order for the pepsin to function, the optimum pH is really acidic, around 2. Okay, so as you know, the stomach will produce hydrochloric acids. Okay, hydrochloric acids that contribute to the acidic condition in the stomach that causes that pepsin to be activated. Okay, so the other enzyme here you see is the trypsin. Okay, so trypsin is the enzyme produced by pancreas. Okay, that works in the intestine, and also the intestine also capable of producing its own enzyme. Okay, so in order for this enzyme to work at its optimum rate of reaction, so the optimum pH will be basic, around 8. Okay, around 8. So it says here, changes in pH is due to the presence of these hydrogen ions and also hydroxide ions. If the pH is acidic, so you have higher concentration of hydrogen ions. If the pH is basic, you have higher concentration of hydroxide ion. Okay, so the presence of this ion, okay, changes to the ionic charges on active site. So the presence of these ions, okay, at different pH will affect the ionic charges, okay, ionic charges on the active site. Awak kena ingat balik, chapter ni dia ada kaitan dengan chapter protein. Awal-awal dulu awak kena fahamkan macam mana struktur protein. Protein ni dia terdiri daripada apa? Amino acids kan? Protein adalah terdiri daripada amino acids. Sama juga. Enzyme ni adalah protein yang dia punya monomer dia adalah amino acids. So kena ingat balik struktur amino acid. Amino acid ada beberapa jenis kan? Bergantung kepada dia punya side chain. Okay, kita ada polar amino acid, kita ada acidic amino acid, kita ada basic amino acids kan? Dia bergantung kepada side chain. So macam mana protein ni boleh terhasil, okay, the globular shape ni boleh terhasil disebabkan oleh interaction between the side chain of amino acid in the protein molecule. Okay, so bila protein ni fall into specific shape disebabkan oleh salah satunya, okay, boleh terjadi disebabkan oleh interaction between acidic and basic side chain of amino acid. Acidic and basic amino acid. Acidic dia akan becas apa? COO negatif kan? Side chain dia. Kalau amino acid yang lagi satu, side chain dia adalah basic NH3+. Okay, so the plus of NH3 and the COO negative tu akan form ionic bonds. Okay, ionic bonds. So this ionic bond ni akan hold the specific shape of the enzyme. Okay, so that's why enzyme tu perlu berada pada pH yang tertentu untuk maintain this interaction. Okay, tapi kalau awak tukar pH ni, dia akan menyebabkan concentration of hydrogen ion dengan hydroxide ion ni berubah. Bila dia berubah, dia akan kacau ikatan ionic bond dalam active site of enzyme tu. Bila dia kacau, the ionic bond can be broken and causes the enzyme to be, for example, denatured. Okay, because the different concentration of hydrogen ion and hydroxide ion tu dia akan it may cause the bonds to be broken and causes the enzyme to be denatured later. Okay, like this. Okay, so it breaks weak bonds. Okay, which is one of it is the ionic bonds. Okay, that are found in the active site of enzyme. So this will alter the 3D shape of the active site. Bila jumpa perkataan alter the 3D shape of enzyme tu is the globular shape of the enzyme, the functional shape of the enzyme, 3D shape, the globular shape of the enzyme. Okay, so once the enzyme is denatured, the shape of the enzyme is destroyed, okay, alters the 3D shape of the enzyme. So therefore, the active site now has different shape, okay, loses its functional shape, so substrate cannot bind to the active site, and the rate of reaction will decrease and less product will be produced, or no product at all if the reaction stops. Okay, so that is the effects of pH. Okay, yang ni saya tambah sikit. So at extreme temperature, rate of reaction stops. Okay, the specific 3D shape of the enzyme is altered and enzyme becomes denatured. Okay, because the enzyme loses its functional shape. Okay, due to the breaking of weak bonds that hold the shape of the enzyme together. Okay, so the effects of pH is normally reversible. You can if you change the pH back to its optimum pH, it may restore the shape of the enzyme if the enzyme is not yet denatured. Tapi kalau denatured, dah tak boleh dah. Or dah tak boleh nak reverse the reaction. Okay. Okay, so these one are examples, okay, of different enzymes that and their optimum pH. These are enzymes that are found in the stomach. You can have pepsin, renin, all right, which is the optimum pH is really acidic around 2, okay. And then you have the salivary amylase. Okay, salivary amylase are the enzyme that are found in your saliva, in your oral cavity, produced by the salivary glands, okay, which is the optimum pH is around 6.8, basic, not basic, around natural, okay, around natural pH. And then you can have trypsin, pH is 7.8, and then pancreatic amylase is 9, okay. Okay, so kita break dulu before we enter into enzyme kinetics. So far ada soalan ke? Any questions? Yeah.
Kan enzyme substrate complex tu dia terbentuk daripada temporary covalent bond. Masa dia jadi produk, apa yang buatkan covalent bond to break?
Okay, bila substrate bind kepada active site, kena betulkan dia punya arrangement sikit. Enzyme binds to the active site, baru dia akan terbentuk enzyme substrate complex. Okay, tadi saya mention pasal cofactor kan. Untuk enzyme ni berada dalam keadaan yang active form, kena ada cofactor juga dalam active site. Salah satu fungsi cofactor adalah dia akan terlibat dalam chemical reactions tu. Dalam substrate adalah chemical molecule kan. So dalam chemical molecule tu obviously dia akan ada dia punya own covalent bond. Fungsi cofactor ni, salah satu fungsi cofactor ni adalah untuk tarik contohnya elektron. Okay, contohnya tarik elektron daripada covalent bond within the substrate. Okay, so dia akan menyebabkan bonds within the substrate starts to break, and then it can involve in the chemical reaction also by forming new covalent bonds. Macam tu. Okay, sebelum dia ditukarkan menjadi, dia tu maksudnya produk ditukarkan menjadi, substrate ditukarkan menjadi products. Okay, itu peranan cofactor dalam active site tu. Dia akan terlibat, dia boleh terlibat secara langsung dalam tindak balas kimia tu. Okay, dengan cara salah satu dia akan tarik elektron, sumbang elektron ke, bila dia sumbang dia akan form covalent bond. Ini chemistry, kena faham konsep chemistry lah kan. Oxidation, reduction reaction macam tu. Faham ke? Boleh? Bila bonds start to break, form new bonds tu, itu istilah yang kita namakan sebagai transition state sebelum dia ubah jadi produk.
Thank you, Dr.
Boleh ke? Faham?
Thank you, Adam.
Thank you, tak faham ke tak?
Better daripada sebelum ni.
Okay. So yang ni maybe kalau kita masuk kepada cofactor dengan classification of enzyme, awak akan lebih faham. Okay. Yang lain? Tak ada So saya bagi masa awak 2 minit untuk kita break sekejap, nak pergi minum air ke, nak pergi basuh muka ke apa ke, boleh 2 minit. Okay, so the next subtopic is on 4.4, which is enzyme kinetics. Okay, so you have to understand what is enzyme kinetics. Okay, so it is the study of reaction rates of biological catalysts. Okay, the study of reaction rates of biological catalysts. So in what is kinetic? The movement, right? The movement of enzymes. Okay, so in order for enzyme to catalyze the reaction, the enzyme needs to collide with the substrate, okay, in order to form the enzyme substrate complex, okay, so that it can catalyze the reaction, and you can measure the rate of reactions. Okay, so you have here is a graph, okay, which is okay, here is a graph. The y-axis, it shows you the velocity of the rate of reaction. Okay, the rate of reaction is velocity. Okay, so the x-axis here is the substrate concentration. So here in the graph, it gives you the concentration of substrate in, for example, millimole. Okay, millimole per liter. Bergantunglah, soalan bergantung. Kalau dalam contoh ni dia bagi dalam bentuk millimole. ada juga kalau tengok graf dia dalam bentuk micromole kan. So bergantung kepada keadaan soalan tu. Okay, keadaan situation reaction tu. Okay. So yang ni kalau velocity dia bagi in micromole of product form per liter per minute. So sebab dia rate kan, rate. So per minute lah. So boleh juga ada graf lain dia boleh bagi contoh dalam bentuk per second kan. So bergantung kepada keadaan. Bergantung kepada soalan. Tak semestinya fix macam ni. Okay, so so it says here in an enzyme catalyzed reaction, a hyperbolic curve is obtained. So this is a graph, we call it as hyperbolic curve. Okay, so if velocity, which is rate of reaction, is plotted against substrate concentration, okay, if there is large excess of substrate, so it means that the substrate concentration now is not the limiting factor. You always add on the substrate concentration. Okay, but the limiting factor here is the enzyme concentration. Enzyme concentration is held constant. So you will get a saturation plot, okay, which is the hyperbolic curve here. So why? Because enzyme is the limiting factor. You keep on adding the substrate, but if you have certain amount of enzyme, at some point of the reaction, when you keep on adding the substrate, all of the active site is now occupied with the substrate, and so therefore the rate of reaction reaches its maximum rate of reaction, which is Vmax. Okay, reaction reaches its maximum rate of reaction, which is maximum velocity. Okay, so this point, all of the active site of enzyme is saturated with substrate. Okay, large substrate but limited amount of enzyme. Okay, so it says here at the beginning of the reaction. So this is the beginning of reaction where you have low amount of substrate. Okay, low amount of substrate. The velocity of the reaction, the rate of reaction increases linearly. Okay, you have high rate of reaction occurs, which increases linearly with increasing substrate concentration. Why? At this point here, you have plenty. You have plenty amount of substrate for the you have plenty amount of enzyme for the substrate to bind to. Okay, awak ada banyak at this point, awak ada banyak awak still ada banyak enzyme untuk substrate bind kepada enzyme tu. So that's why rate of reaction increases linearly at this point here. Okay, so but as the substrate concentration starts to increase, okay, you start to increase the substrate concentration, the velocity of the reaction or the rate of reaction reaches its maximum rate of reaction. Okay, so the rate of reaction reaches maximum rate of reaction or Vmax, maximum velocity. Okay, so this is because the enzyme concentration now is the limiting factor. All of the active site is now saturated with substrate. Okay, adding more substrate will not increase rate of reaction because all active site of the enzyme are saturated with substrate molecule. So makin banyak awak add substrate, tapi bila awak ada limited amount of enzyme, tak guna. Sebab apa? Sebab kesemua active site ni dah terbind kepada substrate. Okay, dia tak sempat nak catalyze reaction, tak sempat nak produce product, tapi awak tambah substrate. So eventually the rate of reaction reaches maximum rate of reaction. Okay, so Michaelis-Menten, okay, Michaelis-Menten Kinetics. So it is a model that explains one, how enzyme enhances the rate of reaction, okay, the rate of reaction, and then how rate of reaction depends on the concentration of enzyme and also concentration of substrate. Okay, from the graph you can tell what is the maximum substrate that you need for the reaction to occur at its maximum point, okay, without wasting any substrate. Okay, okay. So Michaelis-Menten Kinetics. So VI is the initial velocity. So it is measured in moles per minutes per time. Okay, per time. Time can be in minutes, can be in second. Okay, and then substrate concentration are measured in molar, and then Vmax. Okay, Vmax is the maximum velocity or the maximum rate of reaction occurs when the enzyme is saturated with substrate. Okay, all active site is occupied with substrate. The more that you add a substrate, the reaction rate will reach its maximum rate of reaction. And then from the plot, you can determine the Km value. What is Km value? Km value is Michaelis-Menten constant. So what does it tell? Or how do you get the Km value? It is substrate concentration at half Vmax. So let's say the maximum velocity is 100. Okay, 100 here. Okay, 100. So Km value is when you get the substrate concentration at half Vmax. Okay, so bila di sini 100 maximum velocity, so half Vmax is 50. So from here you can determine the Km value. Okay, which is the substrate concentration at half Vmax. Kalau tengok dalam video by Madam Nora, dia guna istilah 1/2 Vmax. Sama je. Okay, 1/2, half is the same value. Okay, istilah 1/2 is the same as half. Okay, so dia lain tau, 1 and a half. 1 and a half is 1.5. So guna istilah tu betul-betul ya. 1/2 is equal to half, or kalau 1 and a half is 1.5. Okay. So jangan ingat dalam video tu guna istilah salah ya. 1/2 is also 1 and a half. Okay. So substrate concentration at half Vmax. Okay, so Michaelis-Menten constant Km, so it's substrate concentration at half Vmax, okay, ataupun 1/2 Vmax. So it is a measure of the affinity of enzyme for its substrate. Okay, so from the Km value, you can tell whether the reaction will occur quickly or not. Okay, from the Km value, you will know whether the rate of reaction is fast or not. Okay. So it says here, the smaller the Km value, okay, Km value is small, okay. So the higher the affinity of enzyme for its substrate. It means that bila letak je sedikit substrate ke dalam reaction tu, okay, terus enzyme to catalyze reaction because the enzyme has higher affinity to bind to the substrate. Okay, so when you add a small amount of substrate, okay, so the enzyme will straight away catalyze the reaction. Lower substrate concentration needed to reach half Vmax. The more strongly enzyme binds to the substrate, and the more likely the product produced. So you want now this substrate with the lower Km value. If the substrate has high, is a substrate. If a substrate has high Km value, so it means that the rate of reaction will occur slow. Okay, because the enzyme will have low affinity for the enzyme and less product will be produced. So mana yang awak nak substrate that has lower Km value. Okay, because more product will be produced because the enzyme will have higher affinity for the substrate. Okay, so the next term is turnover number or Kcat. Okay, so which is the maximum number of substrate molecules converted into product per second. So this is the outcome. You want the turnover number. How much substrate is converted into products. Okay, the maximum number of substrate converted into product. That is Kcat, turnover number. Okay, so next. What is the significance? What is the importance? Okay, what is the importance of you determining the Km value and the Vmax value? Okay, kenapa nak tahu Km value ni dengan Vmax value ni? Supaya yang pertama, Km value ni. So as you know, Km is a measure of substrate required for significant catalysis to occur. Okay, so how much substrate concentration is needed to start the reaction? Okay, so Km value for a particular enzyme depends on the identity of the substrate, temperature, pH, and presence of inhibitor. Okay, so these are the factors. Okay, these are the factors that affects Km value for a particular reaction to occur. Okay, a reaction that is catalyzed by enzyme to occur. So for example, okay, so if an enzyme can catalyze a reaction with two similar substrate, such as for example glucose and fructose. As you know, glucose and fructose, kalau kita tengok chapter 1 hari tu, carbohydrates, glucose and fructose are isomer of each other. They are structural isomers, okay? So they have similar shapes. Okay, so the enzyme can take either two of these substrate, but the enzyme will prefer substrate, okay, will prefer substrate with the lower Km value. Glucose and fructose are isomer, they have similar shape, okay. So the enzyme will only prefer substrate with the lower Km value. Why? Because the substrate with the lower Km value will have higher affinity to bind to the enzyme, okay, higher affinity to bind to the enzyme to catalyze reaction to produce more products, okay. So by knowing the Km value, you can compare the efficiency of different enzyme or same enzyme from different sources. So you know which enzyme is more efficient to catalyze the reaction. Okay. And then what is the significance of Vmax? Okay. So as you know, the Vmax is the rate of reaction when the enzyme is saturated by substrate. The maximum velocity or rate of reaction for the enzyme to catalyze the reaction. Okay. So from the Vmax value, you will know, okay, you will know the maximum number of substrate molecule that is converted to product per second. So from the Vmax value, you can determine the Kcat value, okay, the turnover rate. From the Vmax value, you can know this value, turnover number. What is the maximum number of substrate that is converted into product, okay? So that is the significance of you knowing the Km value and the Vmax value. Km value supaya boleh tahu mana substrate yang ada lagi banyak, mana substrate yang ada low Km value, so that more product will be produced because the enzyme has higher affinity for the substrate. Daripada Vmax, awak boleh tahu Kcat value, okay? Berapa banyak substrate ataupun berapa jumlah maksimum substrate yang akan ditukarkan kepada produk per unit of time, okay? Okay, so next, Michaelis-Menten constant. The values of Km are measured in terms of molarity. Okay, it is the substrate concentration kan, so they are measured in molarity. Substrate concentration at half Vmax, okay? So typically the value of Km for most enzyme ranges between 1 micromole to 1 millimole. Okay, 1 micromole to 1 millimole. And then the next one, to obtain the Vmax and the Km values from this graph is not too accurate, so it is just an estimation. Daripada graph ni, okay, you can determine the Vmax value and the Km value, but because the data is too much, kan nampak, the 50 sampai 150 sampai 100 kat sini, so the actual value for Vmax and Km that you obtain from this graph is not too accurate. Okay, how to obtain the accurate value for Vmax and also Km? You have to convert this graph into Lineweaver-Burk plot. Okay, convert this graph into a Lineweaver-Burk plot. What is Lineweaver-Burk plot? It is a double reciprocal plot. Double. Why is it double? Because you want over. You have to 1 over each value of velocity and substrate concentration. Okay, so the y-axis is 1 over v, the x-axis is 1 over substrate concentration. Okay, so that's why we call it as double reciprocal plot. Okay, both velocity and substrate you 1 over can. Okay, so from that you will obtain a straight line plot. Tadi hyperbolic. Okay, this one you produce a hyperbolic graph, but this one you will obtain a straight graph. Okay, so this will provide a more precise way to determine the value of Vmax and Km. Okay, so where the x-intercept kat sini kan, so ini bahagian dia adalah bahagian graf yang bervalue negatif. Okay. So where the graph intersect, okay, it intersects the intersect the x-axis, it will give you the 1 over km value. Okay, from this you can determine the actual km value from this one. From the intersect value, you can determine the actual km value. Where the y-axis intersect, okay, you can determine the value of Vmax. Okay, the value of the Vmax. So the slope is ini kita separuh kan, km per Vmax. Okay. So basically, Lineweaver-Burk plot transform a hyperbolic plot of Michaelis-Menten Kinetics into a linear plot. So daripada graph ni, awak nak cari value yang mana di intersect ni. Okay. So daripada kawasan yang dia intersect ni, you can determine the Vmax and the km value. Okay. So kat sini ada satu exercise. Then maksudnya kat sini, let's say lah, kalau value dia kat sini 1 over 9 lah, let's say. Kan? Adalah 1 over km. Kat sini value dia awak dapat 9. Awak dapat 9, let's say kan. So in order for you to get the km value, you just exchange the place lah. Kan, basic mathematical concept or formula. Kan, so ini awak bawa ke bawah 1/9, then you get the km value. Okay, which is 1 over 9. So value dia akan menjadi lebih kecil lah, kan, dalam bentuk perpuluhan. Sama juga kalau yang sorry, ini Vmax. Yang ini adalah untuk Vmax. Ini adalah Vmax. So from the graph you can determine the maximum velocity for the reaction. Okay. Sama juga kat sini 1 over km. So walaupun kat sini value dia negatif, you cannot give the substrate concentration as a negative value. So dia dalam bentuk bentuk yang bukan negatif lah sebenarnya. Okay, macam ni. So you get a positive substrate concentration. Okay, a positive value. So let's say lah kalau kat sini value dia let's say 10 kan, so maksudnya 10 lah kat sini. So then you exchange the place, so you get 1 over 10 for the km value. Okay, dengan unit dia sekali. Okay, so here is a graph, a table, okay, for you to do an exercise you have to draw, okay, a graph to plot Vmax, velocity over versus substrate concentration to get the Michaelis-Menten Kinetics graph tu, okay, the hyperbolic graph, and then from this value you have to do a double reciprocal plot, which is the Lineweaver-Burk plot, and then from that you have to calculate the Vmax and the km value that you get from the Lineweaver-Burk plot. So selalunya dalam exam, yang dalam contoh ni dia tak bagi unit, tapi selalunya dia akan bagi unit. Okay, so let's say lah ini dalam millimole per liter. Okay, so velocity millimole per liter per minute. So setiap kali awak bagi jawapan untuk value Vmax dengan km ni mesti disertakan dengan unit. Faham? So kalau awak dah pernah buat graph, awak dah pernah cari value dia tapi awak tak letakkan unit, jawapan awak salah. Faham So saya nak bagi daripada soalan ni, cuba awak cari, kita ada dalam 10 minit, cuba awak cari Vmax value dengan km value. You have to you have to plot the graph. Roughly try to plot the graph daripada table ni. Dua graph yang kena buat. Satu Michaelis-Menten, satu lagi adalah Lineweaver-Burk Plot. Boleh buat sekarang. Faham ke? Ada soalan nak tanya tak? Do you have any questions? Dah klik-klik ke saya cakap seorang-seorang selama ni?
Tak ada soalan, madam.
Boleh? Tengah nak buat ke apa?
Tengah buat graf.
Cuba try buat graph. Ingat je kalau untuk Lineweaver-Burk plot awak kena 1 over kan setiap value tu. Baru awak boleh dapat a straight line. Okay, so kalau buat graph tu sepatutnya kalau untuk Michaelis-Menten hyperbolic graph tu roughly awak akan dapat macam ni if you plot. Ini sebab saya guna Excel kan. It is roughly like this. If you plot the graph. And then kalau untuk Lineweaver-Burk plot kan, if you want over each values ni, okay, the value of 1 over substrate concentration, 1 over velocity, so you get a bigger values, okay, you get bigger values. So that's why kalau tadi kan dia cakap kalau daripada hyperbolic graph ni bila nak determine Km value dengan Vmax ni is not too accurate sebab tengok dia punya value dia is too small, okay, dalam bentuk perpuluhan. Sebab tu awak nak kena convertkan dia kepada Lineweaver-Burk plot. Bila awak 1 over kan setiap value tu, the value will be a bigger value. Okay, so when it gives you a bigger value, bila awak plot graph tu awak akan dapat a straight line. Okay, a straight line yang akan rentas, okay, paksi Y dengan paksi X. Tapi paksi X tu dia akan masuk ke region yang negatif. Tapi bila nak cari Km value tu, Km value is substrate concentration, you cannot give the substrate concentration as a negative value. Faham? Okay. So, ini jawapan dia. Kalau plot lah kan, lebih kurang macam ni lah. Vmax dapat dalam 1 over 9 which is around 0.11. And then Km value you get 1 over 11, okay, which is 0.09. Macam tu lah lebih kurang. Okay. So sebab tu kita kena buat Lineweaver-Burk plot so that you get a bigger value to get a more accurate Vmax value and a more accurate Km value. Boleh? Faham?
Faham, madam.
Faham, madam. Faham, madam. So far ada soalan nak tanya?
Alhamdulillah tak ada.
Okay. So minggu depan kita akan masuk kepada subtopik yang seterusnya. Sebelum awak leave the meeting, okay? So I need you all to sign the attendance. So ini saya bagi. So sign attendance ni sekarang. Dan kalau awak tak ada soalan, you can leave the meeting lah ya. Terima kasih. Jangan lupa lepas ni jawab quiz. Quiz hanya akan dibuka daripada pukul 11 pagi ni, kejap lagi sampai pukul 3 petang. Dengan duration quiz tu adalah selama 20 minit sahaja. Okay. Macam tu. Quiz dekat your future lah macam biasa. Jangan ambil last minute pukul 2:30 kan barulah nak buka.
Okay, madam. Thank you, madam.
Okay, terima kasih.
Sorry, madam. Saya
Thank you, madam.
telefon saya ni problem.
Okay, tak apa. Alright. Thank you, madam. Okay, okay.
Thank you, madam.
Okay. Thank you, madam.
Okay, madam.
Welcome. Salam. Okay. Okay.
Thank you, madam.
Okay.